Alright, is it good now? Okay. Everyone ready? A few people still going? Anyone doing the exercise? Yes? No? Yeah? Yeah, right, okay, cool. So, CMake. Who knows what CMake is? Of course you know what CMake is. Who doesn't know what CMake is?
Hands up.
Wow. Cool, okay. So, CMake is a build system generator, strictly speaking, which generates build systems. Very descriptive stuff. So in practice what that actually means is that you write your CMake script, you tell it your source code, what your source code files are, and then when you actually run CMake and it reads this file, depending on what platform you're building on, it just generates the build system. So for example on Windows, the build system is a Visual Studio project. On Linux, the build system is, say, a make file. On macOS, it's an Xcode project. It generates the build system for you. And it's great because it works on several different platforms, and you only have to write it once. So the key concept with CMake is that you have to define a project, which is actually reasonably simple. It's just a one-liner at the top. And if any of you have got CLion and you've done what we said previously, make that project, you will see a CMake lists.txt. That is the build script. And if you open it up, you'll find it's reasonably compact. And the project is the starting point of any CMake lists. It defines sort of just a logical group that you consider everything to be part of within that script. It doesn't represent an executable or a library or anything, it's just a name. So most of the directives written in a CMake script, and this is a very important distinction, only get run when you generate the build. It doesn't apply to all of them, but it's something to be very wary of because it does apply to most of them. What this essentially means is that you can have fancy conditionals and all this other stuff in CMake, right? So like if the compiler is GCC or if it's Microsoft's, then do this thing. The thing is that that if statement is evaluated. Oh, what is this, by the way, Tom? Sorry. Oh, okay. This if statement is only evaluated when you generate your Xcode project or Visual Studio project. Past that point, when you run build inside it, it's not going to run. There are a few exceptions, but very few. Generate. So there's something. So anything that uses a generator expression is the strict term. If you go to the documentation, generator expressions are stuff that can be used when you run the build. It's also actually a suite of things. So when you install CMake, CMake is actually the build part. You also get CPack and CTest for free. CPack is a wonderful, wonderful tool that lets you actually package up your stuff. So CMake will generate your executables and your DLLs and whatever libraries, etc. But CPack will then let you compile it into an MSI file if it's on Windows, or an RPM if it's on Linux, or a deb file. It's got there's a bunch of them, or just a zip file even. Maybe you just want to zip them up and that's enough for you. It'll do all that stuff for you. CTest, on the other hand, is for unit testing. So you can, write a load of Google test unit tests across several different executables, and then you can use CTest to just have it run them all. CTest also supports testing for deliberate failures. So, one simple kind of testing, right, is you could have a static assert in your C++ code. And obviously, static assert is a feature in C++ that says if this assert is false, don't compile. Assert is at runtime, so it will always compile, but then will fail when you run it. Static assert is at compile time, but it has to be something the compiler can figure out when you build it. So an example of static assert would be, assert that the type of something isn't an int or whatever. CTest also lets you validate compilation failures or compilation successes if you wish. You are responsible for deciding how old the CMake you're going to use, that you're going to accept is going to be. So CMake has been around for a very long time, and generally speaking, people that want to be really, really nice will go all the way back to CMake 2.8. We're currently on CMake 3.11. Personally, I would not recommend going back to 2.8. The limitations in terms of what features you get is frankly horrible compared to today. Version 3 is much more convenient to use. You end up writing a lot more scripty rubbish if you go with 2.8. But you could if you're just doing something really trivial. It wouldn't really matter to you.
Can you make something which is treated differently according to your version? One version of the script for CMake 3, one version for older compatibility? Or...
You absolutely could. I personally wouldn't want to be the guy maintaining it. So obviously, sorry. So CMake is a project by Kitware, if I remember the name rightly. Make is, well, GNU Make these days is really the only one. It runs pretty much on Linux and Mac, really. Obviously, Windows doesn't. You can get it if you install like MingGW or not C-Line, Cygwin. But it's got a much more basic syntax. I mean, I wouldn't even necessarily say basic, but much more trivial syntax. So make files are just for, say, get some files, run this, here's the compiler to use, and it's just like an environment variable. Run this thing like cc, get some object out, run this to another command. It's like a way of just chaining up commands, basically, and you can organize files into those commands. Whereas CMake does way more than that. You can't generate a Visual Studio project from a make file. Well, I say that, there's probably some nutcase out there who has done that. But it's not designed for it. CMake is. It's designed to just let you write one script for compiling your code and allow people on whatever platform, Linux, Windows, Mac, to just go off and build it. It makes their life easy. It makes your life easy.
So it's for if you're building a open source project or something like that.
It needn't be open source. Maybe you're just building a cross-platform application. I mean, it's generally more maintainable as well. Like I don't think that.
What is? I'm kind of struggling to get my head around what it's actually there for.
Yeah, exactly. If you're writing a game and inside your company, you use CMake. There's two reasons for using CMake. The first reason is cross-platform. You're building a tool or building some software, not necessarily public, right? Closed source, whatever. But you want to sell it to customers who have Windows and have Mac, and maybe even have Linux as well. So you're developing.
As a customer of lots of companies that never had to build probably have for that moment using all the scripts or something like that.
No, you don't.
I've not had any knowledge.
No, you don't care as a customer. No, you don't. You as a customer don't care, right? You just get the application. The company does because now they've made a saving. The developers are writing cross-platform code. The tech ops guys maintaining it have this, have the CMake that's just written once. They've only had to write the code once. They've only had to write the build script once, and they can just farm it off to their build farm, and it will just go and take it, and boom, Mac version, boom, Linux version, boom, Windows version.
Okay.
So it's a cost saving. It's less maintenance on people, and it's less cost because you've got to do it once.
Have CMake, you would have to run your build, you have to run your compiler for every platform that
you
mobile app.
Yeah.
Well,
Well, he's writing away because those languages sort of extract it up the line. Java, for example, right, is you write it once, run it anywhere. So we've kind of got there now with C++ because the standardization has gotten a lot better. But the tools you get with Java, right, it doesn't matter what platform they run on. It just works, right, because all of that cross-machine stuff is done. They deal with that, right? The Java guys who write the Java virtual machine are dealing with that problem, so you don't have to. So if you use CMake, one less thing to worry about. You've still got to make sure your code is cross-platform. If you start doing Linux-specific stuff in your code, it's just going to blow up when it tries to build on Windows. But that's why you abstract away with libraries and all that kind of stuff. So, on that note, as it happened, it allows you to write scalable build systems for huge interconnected projects. And although, I don't know if Ricky disagrees with me or agrees with me here, CMake, yay or nay? Yeah? Yeah, okay. So, we use it here. King uses it. Am I allowed to mention that? Candy Crush for anyone who's in the know. It's pretty much the industry standard. If you look at the Kit website, Netflix is using it. There's all sorts of companies using it. Granted, it's not. I'm not saying it's the greatest build system ever invented. It's not. But in terms of actually scaling it up, it does work well. And also, it's great for having different projects talk to each other. So I write my project in CMake, and then someone else in the company wrote theirs in CMake. They wrote a library in CMake. It's really super simple for me to now pull in their project because theirs is already written in CMake. Or even open source libraries. If I use an open source library on hobby project or whatever, if they've done that in CMake because I'm already using CMake, it's great.
So how would that compare to like
Containerizing is what you would do with the output. So I write my code, I build it using CMake, so I use CMake to generate the build, and then the thing I've built, the actual software itself after it's compiled, I might containerize that, but in terms of containerization, it doesn't really relate to CMake. I mean, something some people do like to do these days is actually containerize the entire build infrastructure. You can do that. Usually it's more oriented at developers. So for example, you'll containerize it as a Docker image, but that means if you hire someone new, you just go here, run this Docker image, go, everything's on the image. Because it might as well be a VM. But that's really just for convenience of getting newbies quickly working on the code. But yeah, the other caveat is you can just write horrible garbage as well with it. So it's kind of like PHP in that way. you can write PHP well, but I think hopefully everyone agrees that there's just some horrible PHP out there that should never come into existence. Not saying WordPress or anything like that, but WordPress plugins, obviously. WordPress plugins. Yeah, I've come across a few different open source projects that have not done their CMake very well, and I've ended up rewriting it myself. The worst sin I tend to come across, it's not horrific, is they try to set various variables in CMake that you as the builder should be setting, not them, because they're ones that depend on the platform, and I'm like, great, now you've got a script here that will only work on Linux. So I've had to go and then hack that to make it work on Windows as well.
Other than this project, how often do you need to put your hands on CMake? In your daily or weekly or monthly or
Depends really. I can't really think of a frequency too much, because obviously if I'm say integrating a new library, it's fairly obvious I have to. If I'm adding or removing source files, then I need to. Which I can't remember if I mentioned it in this presentation, but there's something called file globbing that CMake can do, and it's a really bad idea to do it. If I don't get to it by the end, I'll bring it up. So the core concepts for people who are building, as it were, this is not the people writing the code, not the people trying to just develop on it, but the people who are going to just want to get an executable or a library out of it and use that thing. The CMake command on your command line will generate the native build system for you. So you can specify what it is you want. So maybe you want a Makefile, or you want Visual Studio, or you want Xcode, whatever. You just -G, whatever. Did I put this in? No, I just said it though. The default build type, this is important. The default build type, CMake_build_type, is debug by default, which if you're a developer you don't really care. But if you've got this application you're about to stick on a really expensive server that's planning to, you're planning to serve millions of people with, you probably don't want the debug build, it's going to be really slow. So you have to tell CMake build type equals release, and then you get the nice fast one. There are massive amount of variables inside CMake to let you control the actual output. So you can tell it what folder you'd like it to install to, the simple stuff, what build type, what arguments you'd like to pass to the compiler, what arguments you'd like to pass to the compiler if it's going to be an executable, or if it's going to be a library, what arguments to pass to the linker. It just goes on and on and on. And it's all very well documented, fortunately. CMake has very good documentation. However, as I said before, badly written CMake lists will cause varying degrees of pain. Try generating a link time optimized build of your project if you've got one that's doing something fairly sensible, and if you're able to get there without touching the CMake lists, you're doing something right. Now for developers. So it's structured with an overarching project, which is literally the first line. If you look in C line, you'll see that first line, project, my project. Which consists of the various targets. So a target is will result in a tangible thing. So you can have one target that's add executable. That's obviously a program you can run. And then you can have another target that's add library. That's a DLL on Windows or .so on Linux. You get a .a as well if you want a static library. And then there's custom targets as well. So maybe you just want to generate a zip file of cat pictures, then you can. You generate targets by telling it what source code is for which target. So, for example, add executable parentheses. The name of the executable file should be like my cool program.exe. Well, you don't need the .exe, and then just a list of CPP files like a.cpp, b.cpp, blah blah blah, and they all just get compiled. And it provides rich capabilities for tracking dependencies. So you can, for example, have some of your source code compile into a library. And when you do that with add library, you give it a name. That is now an identifier. You can then do an executable, but make it depend on the library that you previously built. So, or you can pull in an external library. This is where the CMake, if someone else does a library in CMake, this is where it gets good, because I can pull that in, and their library's got a name. So now I can do add dependency and state that my thing depends on their thing. And usually, obviously, it's not just one thing; it's lots of different things. So you can make sure that when you have your application relying on loads of different stuff, this doesn't even have to necessarily be CMake things. If it's just native libraries within the system, so say you don't care about cross-platform, but you want, say, image magic, right? The image magic libraries that let you do graphics manipulation. You can get CMake to. Sorry,
is that instead of using includes in the code?
No, you still use the includes, right?
Right.
But what CMake does for you, because when you do that, you don't do include and then like /users/libs. You don't do the full path on your hard drive, right? You're not going to do C program files, blah blah blah, for example. Yeah,
Okay.
you're just gonna have an assumed relative path, and you assume that that's going to be in the path for all on your system of all the available libraries. What CMake does is you can do find package, and then CMake goes off and it looks for ImageMagic's headers, and it looks for ImageMagic's .lib files on Windows or .so on Linux.
If you take some source code and compile it on Linux, you do that /config. Is that basically slightly different?
That's AutoTools. Yeah, that's AutoTools. CMake skips the ./configure part basically. Or it doesn't skip it. When you run CMake, that is the ./configure part. And then all you have after that on Linux by default is make. It will just build because it got configured by CMake. But yeah, that's AutoTools. And it all starts with a CMake lists.txt. You can structure it however you want past that point. You can have other weirdly named wonderful files in all kinds of folders, but whatever working directory you're in at your console, CMake expects to find that file. It can reference whatever other files you want for the build script, but you must have that one first. So, the simplest of all CMakes.
Is this the only file you don't
CMake lists.
Yeah, because I was just looking at the big CMake folder in the project. CMake.
Oh no, CMake. That is the build output. That's the build output. So when you use CMake, I think I might get to this, but when you use CMake, your folder where you actually do the build should be separate from where your actual source tree is. One, because you're usually versioning your source code. You don't want to pollute it with a load of object files and other crap. So you just go off somewhere else in the file system to do the build. Keep the actual source tree clean. So, very simple CMake. First one states the minimum version we're going to support. I have generously put 3.2. The name of the project, which again, it really just sets a variable that you can use elsewhere if you really care. It doesn't represent anything particularly tangible. Add executable, which I have decided to call you can run me. So this you can run me would be a .exe on Windows. Obviously wouldn't have any potential on Linux because it doesn't include. And I decided I'm linking my main.cpp because that's where my main is, and you execute the main. Extra stuff doesn't really matter. Source file and the header. Now, there's a specific reason for including the header, because I'm sure as you'd all expect, the header shouldn't have any actual executable code in it, right? Generally speaking, it can define stuff, but you shouldn't really put definitions into headers. But there is a good reason why this is good practice. And the reason is simple. If people use your CMake lists to generate Visual Studio projects or Xcode projects, anything that's an IDE, basically, it's just going to generate from an IDE and give them a full dev environment. This is being courteous. If you don't include it, they'll be able to generate their Visual Studio project just fine. They'll even be able to build it just fine. But obviously, when you use an IDE, it gives you a list of source files, right? If you don't include this, they won't see it. Well, they'll see this and they'll see this. They'll be able to go into this and they'll probably notice you've included this. It won't show up in the actual project. So if you do care about people using IDEs, note down the headers as well. Incidentally, CMake is also smart. It doesn't actually try and go and compile your header files. It just references them. But now let's add a little bit more, right? So we're getting a little bit more fancy. So this is obviously a target, right? You could run me is a target. It's a name which represents it inside CMake. It's also going to be the name on the hard drive. Although you can actually override that.
Can you give folder names for both where all the files are? I can imagine that list of files getting a lot of
Yeah.
You literally have to manually.
I mean, you could do like, if I wanted to do like an SRC folder, I could just do src/main.cpp.
Yeah, but can we do, if I've got like 30 files in SRC, can I do SRC?
No. I know what you're thinking.
You literally have to list
Every
single file.
So there's so this is where we're getting into the idea of having it detect. There's something called file glob, and you can pass it a directory and have it just dump out into a variable all files in that directory. There's one massive caveat to it, which will bite you. It will bite you eventually, which is that the processing to figure out what files are in that directory happens once. Happens once when you run CMake. So if you not so much changing a file, but if you forget to run if you don't run CMake, if you just run make, right? You just run make. That doesn't run make doesn't run CMake. Now if you change the CMake list, so for example, if I physically change some text in CMake lists, and I forget to run CMake, I just directly run say make, or I just hit build in Visual Studio because it was Visual Studio generated, it will detect that my CMake list has changed. Will regenerate it. But if you have this clever, if you're trying to be clever and use file, glob, whatever, right? You run it once to generate the project, and it generates, and then obviously it will never change the file. You think you have no reason to change the file because it's got this wonderful detection, except it's not actually going to detect anything because it already ran that part. That happened when you first generated. So you end up shooting yourself in the foot if you do it. You could maybe try and build something clever around it, constantly rerun CMake, and then you could think, yeah, okay, I can do this, but kitware themselves, they don't do it. This is now our target. This is a name we can actually reference. So the first thing we're going to do is target include directories on this target, and this is simply giving it a path which will be given to the compiler where some headers will live. So this is some ridiculous invented library. And now, anything that lives in this path, I can include in my source code. Because CMake will make sure the compiler is aware of this directory. Then I decide, well, okay, I've got this library headers now from this line, but it's also an actual library file which I need to link to. So we've got the headers sorted, .h file. Now I need to sort out the .lib file, the .so. So we do target link library, again, the name of this thing here, part of the library folder, the library folder library. And then I want to do C++ 14 because that's cool. And, you know, I wrote this before 17 Sam died, so I need to put 17. Set target properties. There's obviously way more than this. But again, the name of target. And you have to write properties because, and then the properties are, and then the actual properties command for the word properties, which is in this case C++ standard I want to use. I want to use C++ 14. And it's required. So if someone runs my build script and they've got a horrifically old compiler, too bad, required, failed. No code for you. And then finally the install directive. So this now says that I would like this target to get installed, get its runtime installed in the bin destination. So wherever bin is depends on the person building it to choose. Maybe you want to stick it in /user/bin. Maybe you prefer to use user local bin. You can decide whether it's user or user local or whatever. I just stick to bin. So how would we typically do a build given an actual script? So firstly, building in the same places where the scripting sources live is not good. I think I mentioned this when someone asked earlier. Make your build directory somewhere else. The nice thing about CMake is it doesn't care where you build it. It just needs to be told where the sources live, and it generates everything out of tree. So the debug build is the simplest one to do because you just call the CMake command in some empty folder, and you give it the path to your source code. So that would be this would be the path to your actual source code, and it just goes off and does it. As you can see, release is a little bit more involved now. CMake and then -d, which says I would like to manually set a variable. And the variable in this case is CMake build type. You could put a space after D if it makes it all fuzzy. Doesn't really matter. Watch out for this as well. Capital R. And again, the path to your source code where your CMake list lives. Now the generators. So there's this -g argument that we can use. Oh, did I not give an example? I didn't give an example. I'm terrible. So to just for so we cover this, you could use -g. It would be CMake -g Ninja or Visual Studio. It wouldn't actually be MSVC. It's like Visual Studio 15. It's actually not a massively pleasant one. The good news is if you are using Windows with CMake, it has a GUI. You just click a drop down and tell it which one you want. Yeah. Okay, so a bit of practice. Head over to this URL. Oh, yeah. Also, if you wish to play around with the tutorial stuff in C-Lion, feel free. Doesn't work, right? Oh, you only conditionally call it, yeah, I see, sorry. Okay. I just ruined your life for that, haven't I?
No.
Well, you know what to do to fix it, right?
Yeah, no, just wind the range. Stop finding that paper for breakfast.
Good. Also, since I forgot to do it at the beginning, and I did promise my colleague I would do it, so I'm going to do it now. Mimecast is currently hiring. If you are a full-stack developer, JavaScript developer, C# developer, almost any kind of developer, and you like the look of what we do here, or at least what we have here, then I'm going to take these business cards and I'm going to lay them out. Please feel free to contact Graham, or you can have a chat with myself if you're intrigued. I think we're a great company, and I'd recommend joining us if you're interested. That's it. I was supposed to do it at the beginning, but I forgot. Yes, so you can go to mimecast.com as well, and when you go to company, we have a careers page. We have a list of roles there in all of our various locations. So if you do just click search and don't enter anything, you're going to see like Boston and Australia and other places. You know, if you fancy moving, great. If not, then click on the London one. Tom, you've got to register the roll call.
Do I have what?
Register, you have names.
Can someone advise where is the page with the names? Because not everybody register. If you wouldn't mind just move it along so people can sign up, that would be appreciated.
Yeah, I forgot Java developers as well, which is funny because that's one of our biggest ones. I'll leave the box here at the front if anyone. Figure out if you're sitting down. If anyone gets through the practice and wants to exercise themselves a bit more, try just finding an existing C-line project without looking, just nuke the entire CMake list and then try making it from scratch. If you've got, for a simple project, it shouldn't be too hard. I will be back with you.
Sorry? I'm so sorry if there is something. Yeah.
I don't understand where it wants us to get a header file. I don't really understand. That's probably what happens.
Yeah, but those are numbers. Well, that's the one for the compiler. So you don't have to include the CMake. The compiler doesn't. But that's like every compiler knows about it. That's what you have to.
I've got
Greater
this
than
to make this text. Where?
Oh well, the compiler header files, the compiler it's your header files that you have to specify. Because the header files come from the compiler.
I'm not taking it.
So the compiler knows the header file. That's the compiler header file. It's your header file, the one you use it. You have to specify. Get CMake is a computer that products from C++. Well, because they're two separate.
Oh, so you just put it in okay, so I just put a header file in the folder.
It's a program that allows you to build and specify how the find a script that goes to tell the compiler what to do.
Okay.
Yeah.
So,
Always.
even the
Yeah. Yes, exactly. Build out, exactly. Yes. So, for example, if you're working on Linux, you can always go to compiler, so to a command line, and type maybe C, compile this, compile that. But also the header file you write, your .env file, you've got to specify that. So that the compiler knows where it is. But all this one comes from the compiler. So the
This is what
compiler knows
confused me. I was like,
where
yeah,
all
it's
of
the
those
same
are.
CXS. Is it
Where they are. That's the header file you write. Yeah. These are lines you write in your code. For example, say sometimes you have when you run sometimes like that, you type name of the program, so we have and then I only know that command like say if you write a program to for then the compiler will tell you that you've got two arguments exactly. So yeah. So you've got two arguments and these are in this well, for example, you might ask actually, I use that the program I want to get from the command line. Well, you don't from the command line.
Okay, but that's a number. That's a number.
Yeah, that's
Okay, all right.
and then that's the array. Exactly, the list of the list of the part of the program. If it's lower than two, if it's one, well then.
Sorry?
On a side.
Yeah. Yeah, because if it's only one part of the command, then it's only part of the program. You only provide
I don't understand what this tutorial got.
But more than one, then we give an one and a half.
Oh wait, this is
The next one is the first.
yeah, I know what A and 5 is.
Samuel? I can't read your surname.
If I have less than two, this is the info. That means you have to use not just one error. It's the header. So when you need to provide more than one type of if that makes sense.
So if I change the name of that file,
Yeah, also, I mean, it's like C-line what I think, yeah, type it.
Yeah.
Type that copy that.
Restricted tray to Z.
Copy it.
Your magic does not do harm. How are we getting on with the exercise?
How are we doing with the exercise? Good? Not good? Cracking away? The header include. Header dot the h.in. Yeah, that way you can get the name.
so are we going to be using a lot of CMake later on in the course?
We focus mainly on the language, but yeah, it's good. This rudimentary knowledge is good because
It's hard to get a sense of how what it's really for, because we're not using it for anything in particular.
yeah.
And
So
it'd be nice to sort of, I mean, I've used like build script, so
yeah.
developer and stuff, but it's hard to get a sense of it in the context of the CMake.
So you are using it. Really, I teach it because if you go off and all you do is do C++ through C-Lion, well, marvelous, right?
Yeah.
The C-Lion, you're still doing it, but this IDE is just doing it for you, which is great if you want to go out and buy a copy of C-Lion, go for it, have fun.
Yeah.
But if you just use free tools, you're gonna need to have this skill, and companies are gonna want you to have the skill anyway.
Yeah, and also
So
like you could go to a company where they make you run their kit as well.
precisely, yeah, precisely.
I've been in companies before where they kind of have worked for a bank before and you can't.
It's what they give you in that sort.
Want you to use.
Yeah. So precisely. So it's a useful skill to have just for that.
Oh yeah.
Knowing on
It's tough to-
knowing what's going on inside the machine is always useful, right? If you're also unsure of any of the like any given function that you call in CMake, if you're not quite sure about it, just paste it into Google. Go to the CMake documentation page, read about it. The documentation is quite rich. All right.
I managed to get this to work. I can pick up file copies. So yeah, so you basically need to change this. It does, but you need to also have that.
We'll have to think what's
That's what I'm saying, yeah.
library.
I got it to work once I gave it in.
You say,
Two slides there, which is one of the things. Yeah.
how do you pass command line values to program running with C-line?
Command, you mean
What
like
kind of command line values?
when you like C in
Yeah.
at the bottom, there is a window you should have. Yeah.
So if anyone is finding if anyone's finding this tutorial tedious, then practice does make perfect. We have this wonderful CMake 101. You can clone this from GitHub. There is also a solutions branch, so if you can't figure out a given challenge, I have a solutions branch that just shows you what to do. Although these are my own challenges.
All right. No, I was trying to figure out what because he knows that. I was trying to understand exactly what was said, what those parameters actually are. We're trying to know how do you specify those arguments?
You don't specify them here. The CMake is here. So you don't want to spread all the settings. So you see here, you make like Assert. So you say main. Tom has it here.
On the side, if you open my back on the small pocket on the other side. Yeah.
For example, you command here. Yes. Class. Class. Let's say call this test. Here. Yeah. If I delete that, so let's do this. How do I
you pass it on mistakes? Yes. Right click, not right click. Yes.
This one
And
your main will run it. Because when you try to build, they American that's wire. So before you go,
you could also just run it on the command line of your Mac as well.
I go back here.
No, so you've already built it, so you can just go to where it's built, and you know how you run like ls or make dir, right? You would literally run it the same way. You just do like / the name of it, and then space 9. Yeah.
I wouldn't be using here, yes. I wouldn't be using here arguments. I suspect you don't have to make all the calculations otherwise.
Yeah, I just copied that content into PHP and then made sure, and then I included it here. I'm not sure. And then
following the tutorial.
I don't know why.
Just following
It's, yeah, I've got it listed there, but I don't know why it works.
On the website, not from tutorial. Yeah.
Alright, 5 minutes away. Let's wrap up.
Never made any money.
Should we wrap up? Okay, it's getting close to 9, so we're going to wrap up now, but we do have a little bit of time left before 9, so we should have done this for the pointers. I don't know why you didn't put a slide in, terrible. Any questions? Pointers, CMake, whatever, feel free to ask now. Any questions at all? Going once, going twice? No. Did everyone really understand it that well? It was all so clear to them, they grasped everything that quickly. One at the back. Your question was that you have no. That's a statement. That's not a question.
Yeah.
I have no question. Okay.
There might be one online question.
Oh, we might have an online question.
I'm just trying to get the correction.
So maybe a more general question. Who's willing to answer how? Who's willing to say how they now understand pointers, even if it's completely vague? Go on. Tell us what you understood from pointers. Oh, okay, never mind then. Okay, fine. Anyone want to give it a shot?
Can you show us the result of exercise 3, chapter?
Let me see if I can make that happen. Chapter 13. Tom's going to volunteer his solution, which I know works, which we'll go through.
I'll pass you on Slack.
Yeah, paste it as a snippet.
I think the pointer is straightforward when you just say it just represents a memory address. It's actually when you try and start manipulating things like functions, it gets quite confusing quite quickly.
It can do, yeah.
I think it just needs to settle in.
Yeah. So we have his example here, which I'm going to try and enlarge. We'll see how it goes. Or can we hide this part?
I'll move outside of the screen.
That was not what I wanted to do. Sorry?
I will move to the side and disappear.
Move what, sorry? You know, I've got a better idea. Hold on. Do this. Yeah, cool. Let's make it even bigger and make it even bigger.
I can go smarter.
Okay, can everybody sit up?
Is that readable?
I mean, sorry about the mess.
Which one to start from, main?
Yeah. So the exercise.
Do you want to say it or should I? Do you want me to do it? It's up to you. You wrote it.
Okay, I can do it.
I can do it if you want.
Sorry. Well, I made bigger ASCII code. Basically, we're working on ASCII code. So what I did there is, let me just quickly.
That's what I mean.
65 is so bigger than 60. Yeah, so it should be 65 actually. Yeah, you're right. So what I did here is I'm creating a string called name and name2, only for testing me the other 5 in the space, and obviously capital H, capital O, capital W's. So here on this line, I'm just printing out to prove that this prints correctly, so nothing funny is happening. This is I just added for debug, so I know which line it prints out. Now I create a range loop, so I'm starting auto, and I'm using here a reference. Anybody knows why I'm using reference? Okay, I'm using a reference because if I wouldn't use it, then I would create a copy of my string. So basically I would be working on a temporary copy of that string. And I don't want that. I want to basically change the value of that string, of this particular string, not a copy of it. So I'm iterating, going through, the I is going to be every element inside my name. So basically you'll go 5 space A-E-L-L-O, and that's it. So what I do here, I put a statement that if I is bigger, it should be 65, bigger, and yeah, but 64 is at, so it should be. Actually, yeah, it's correct. Yeah,
I want to make a quick. I want to make a quick point here. The fact that you two are discussing this shows how much time you're wasting. And instead of writing 64, you could have written in single quotes the actual character below A.
You're right.
And you could have then written in quotes the character above A. Or, just to make it even more readable, and this is a style thing, this could have been A, literally in single quotes, and that could have been Z in single quotes. And then you, of course, had equals or greater than, equals or less than.
Okay, thank you. Experience.
Yeah, obviously real programmers should just read the numbers, they should have it memorized. That's what real coders are.
When you wake up, you should always repeat, you know, the lowercase a is 97. And then I'm calling my function, so I'm sending the reference to I, which is the character. So if we go a little bit up, then we'll...
So yeah, so you're calling 2 lower there, which is this.
So he basically here I'm receiving a pointer to the car or char. So I'm dereferencing the s and plus equals, so that will be same as the star s plus 32. 32 is the difference between lower and uppercase character.
So if it's a lowercase a, it adds 32 to it to skip it up to where to the value of uppercase.
So the 32 will be added to let's say uppercase is 65. So 65 plus 32 should give us 97.
And just a quick point as well again, which is that there is actually a 2 lower function you can call that does this stuff.
Yeah.
In the C library though, and in the C library it does this check. So this check probably and not just the check, but probably this whole loop should have been put into this function. This function is slightly pointed because it literally does one thing. It would be, but this is there's a comment actually that you can't see because of the screen over here that actually is like / job security. No, I'm joking.
Yeah, so that's it then. Because it's a pointer above there, Okay, because it's a pointer, so I don't have to return anything because I'm working on a variable which is inside the main. That's it.
And that's a working solution. So if we just whip through it, he tests name, he makes name1 become lowercase, and then he makes name2 become lowercase. Does anyone know what a range-based for loop is at this point? I don't think anyone actually knows this. Oh, we did cover them. Okay, cool. So we should have covered these. It's a nice language feature. It's not magically supported by everything. This is a stood string, obviously, which does support it, so this works nicely. Basically what it does is it goes over each character. Because it's a reference and not a copy, this just works fine. If you forgot the ampersand, it can make a copy. And this would still compile and run fine, but it would literally work on a copy. So if you save something you're going to throw away, and the original object would remain unchanged.
So, where's a char is an array of integers.
So a char is actually a number. So it's not saying it's not an array of integers, it's an array of chars still. An integer is bigger. A char is 0 to 127, 126, because it can be negative, right? An unsigned char would be 0 to 255. Cheers. But it's a one byte value. But yeah, human readable characters, they're just mappings, right? They're actually just numeric values that the ASCII set said, okay, this number should look like this on the screen. Sorry? It would still be the same number. In fact, let me show you. So, if we copy this code, and then we'll finish. We can go to this wonderful website called godbolt.org, which has some rubbish I was playing around with to demonstrate something to somebody. So, if we just take this piece here, I just copied it. You know, I'll just demonstrate it this way. Return A. It's a cut. There we go. See there, you get 97. Move EX 97. Don't worry about the reassembly. Just you see the value 97. If you look at an ASCII, I have godbolt.org. It will take any code and then actually you can assemble it. Would you mind to make it bigger? I would like to make it bigger. Not that big.
Can you see it now? Sorry about
Is that visible?
So what about using square brackets in SRA? So instead of using and start, I use S.
So you did like 4 I equals 0.
No, actually, while was no null point to the end of the string. While the index equals 0. Character equals 0.
If you are...
0.
Yeah. So the answer is yes and no. If you're working on a char star,
yes. Sure,
that's null terminated. If you're working on a stood string, it is not actually necessarily null terminated. Yeah. Now you can use .c_str, so you can get a C string out of a stood string. But one, it's not mutable. It's fixed. You're not allowed to change them, and so that breaks it. But it is guaranteed to have a null terminator if you use .c_. There's .data now, which was added, I think, since 11, which is mutable, but that's again not guaranteed to have a null terminator. So because stood string is a class that can hold an arbitrary amount of bytes, it doesn't need a null terminator. It knows the length internally.
And the other thing is, that, to me, the square string, the square bracket.
It's fine. It's okay. I mean, I would suggest using stood string.
Yeah,
what just happened there?
Yeah.
No, it's all about style. It also depends on your use case. But yeah, I mean, when you have a pointer, you can use it as an array, right? I can have a pointer to my own. Yeah, I can have a pointer to my own type. I can have an array of vectors. I can have a pointer to an array of stood vectors, which is silly because a vector is an array. You should just use a vector. Don't do that. But you can have pointers to any type, and then if you allocate enough memory for several of them, and you construct them, then you can just index each one.
Yeah.
also how you can also use it to implement stuff like linked lists, right? You can have a struct T, and then there's a field in struct T, and the type is its own type. So then it can have a called next. So then it can, and that could be a pointer to its own type, so it can keep going along to itself. If it's got more than one member, if you can go from 0 upwards, right? So there's a 0 and there's a 1 and a yeah, sure. Cool. Well, thanks everyone.
Thank you very much, Ollie. Really big thank you for your class. So 3 small things. Next class, same place here, and after that, hopefully we're back. I think we're back to skills matters for a while. Can you please drop your passes to me or Ollie? And now we are heading to club where you can show your appreciation to this gentleman and ensure that while you homework.
Oh, one thing we're missing. There is a survey that we have.
I said that.
Oh, you did cover that.
I did cover that.
Please do the survey. It's very quick, 10 questions. The business cards, if you're interested in Mimecast, are over there as well. So please feel free to take one if you are interested. Those that weren't sitting at the tables.
See you in a pub.
Is the survey online? Or?
It's an online survey, 10 questions, yeah. It's just a survey monkey. So please feel free to take that. And we'll be heading to Beer Schenker shortly. So if you want to join us for a drink.
Yeah, I mean, you're definitely very welcome to help.